Review number 2 for Lucerna for the Unit 4 test. The last few problems here I'm going to go over are 15, 16, 17, and 18, all 4 of those. And 15 and 16 start off with construction. So for number 15, we're given segment AB, construct an equilateral triangle with a compass and straight edge. So I've got my compass, I got my straight edge. Now for the equilateral triangle, this would be the base of the triangle, so you can either draw it down here below or above AB, doesn't matter which. But the first thing we should be doing is just measuring that original segment. So I'm going to try to close this up a bit. I'm going to try to get there. It looks like we've got B from the middle point, the pencil on A. And once I've got it measured, then I'm going to draw an arc like that. Then I'm going to the other side from A, I'm going to draw the same arc. Now that I've got that drawn, I mark the intersection. And with the straight edge, to construct the triangle, all I got to do is that. Connect there. And now I've got one triangle, 3 sides. These all have the same measurement. There's my equilateral triangle. That was a mistake there. It actually looks like a little kind of smile. Number 16. Construct a square using FG as the diameter of a circle with a compass and straight edge. This is going to actually get messy here, because what's going to happen is if this is the diameter, then our circle is going to go over all this. So what we can actually do is we can just kind of redraw FG up a little bit. Now if you want to, if you're good with the construction and you just want to go ahead and draw it from here, that's fine. You can go ahead and do that. This is going to kind of invade the space down here. So I'm going to just redraw it up here and go from there. Now again, they want FG to be the diameter of a circle, which means we have to do a couple things. We have to draw a perpendicular diameter, or bisector, which means I'm going to first start by measuring FG, just like we did AB on the last one. And I'm going to make arcs that are a little bit longer. I'm going to go on one side, and then from the other side through G. And I'm going to connect these. And there's my midpoint. Now they're saying eventually you need a circle. Now normally the circle's drawn for you, where you would know where the center is. This tells us where the center is, though. For a circle that's not drawn yet, we have to draw that circle. So now that I've got the center point, I'm going to measure the center to this outer point. And this time I'm going to go all the way around. And make my circle, which looks absolutely perfect because it went right through F, sort of. Now the whole point of this is that we are eventually trying to construct a square. When I drew that circle, I got the circle 4 points on it, top, bottom, left, and right. When I did that, or when I've got those, I'm connecting them. All 4 of them, and then there is my constructed square inside the circle with FG as the diameter of the circle. Now again, the construction, if you do this on the test, they're going to give you a nice, beautiful, perfect, absolutely 100% perfect circle like that, and you're going to have to draw the diameter. So the diameter is not going to be there for you. You're going to have to draw the diameter like that. And then you have to do what I did with this perpendicular bisector. You're eventually going to get a line going through there. And then you connect those 4 points and get a beautiful, absolutely perfect, 100% great square like I did that on that one. 17, 18, both very similar problems. 17, Laura says all rhombi are parallelograms. Marianne says all parallelograms are rhombi. Who is incorrect and why are they incorrect? When we're comparing like this, rhombi are parallelograms are rhombi, keep the first name Rhombi have, and then think about the definition of the second term. So instead of writing parallelograms, I'm going to say instead of rhombi are, rhombi have, and then I'm going to state what makes a parallelogram a parallelogram. Well, parallelogram has two pairs of parallel sides. Once we can write that statement, then we start to think about whether or not that's a true statement. Now, a rhombi, does a rhombus have two pairs of parallel sides? Yes, it does. They happen to be all the same length. So if I draw a rhombus over here on this side, a rhombus has four congruent sides, but they do also happen to be parallel. So that is true. Now Marianne says all parallelograms are rhombi. If I reverse the statement, parallelograms have four congruent sides. I'm getting four congruent sides from the definition of rhombus. That's what makes a rhombus a rhombus. Now, does a parallelogram always have four congruent sides? Well, no, because I could draw a parallelogram real long like this. The left and the right definitely are not the same length as top and bottom, which means that's the false statement. Now it says who is incorrect? Well, Marianne is incorrect. And why are they incorrect? Not all parallelograms have four congruent sides. You need to state that in the definition, or in your answer, you're stating using the definition of rhombus to answer that. Number 18, very, very similar to that. Number 18, if George says that all rhombuses are squares, Paul will immediately argue that all squares are rhombuses. Who is correct and why are they incorrect? All rhombuses are squares, so like last time, rhombuses have, now what do squares have that make them special? They have four congruent sides and four right angles. So when you think about that statement, rhombuses have four congruent sides. Is that true? Yes. Rhombuses always have four congruent sides, but do they have four right angles? These are not right angles, so the second part is false, which means that's the false statement. Now if we reverse it and say squares are rhombuses, squares have, and the only thing that really makes the rhombus a rhombus, the definition, is that it has four congruent sides. Now, is that always true? Do squares have four congruent sides? Yes. They also happen to have four right angles, but they definitely always have four congruent sides. So they meet the criteria, or the property, for a rhombus. So that is the true statement. Now it says who is incorrect and why are they incorrect? Paul and Lily argue that squares are rhombuses. That's the correct statement. So George is incorrect because not all rhombuses have four right angles. Again, it was the four right angles part about the square definition that threw off the rhombus. There's number 18.